Welcome to part 4 of the OpenOrbis PS4 Toolchain tutorial series, where we go through building homebrew apps for the PlayStation 4. In the last video, we did a sample of how to display graphics on the screen by drawing to the CPU frame buffer for 2D graphics. And in this video, we're going to be doing audio, because video and audio are obviously your two pillars or cornerstones when you're doing game dev and stuff like that. So in this video, we're going to be covering using the SCE audio out library as opposed to the SCE video out library. And we're going to be playing WAV files through the PS4's audio library. And once again, we're going to be using one of those header libraries, just like we did in the last video, for decoding the WAV file because it saves us a ton of work. And there's no need to really reinvent the wheel there. So I'm going to be going bit by bit through the audio WAV sample. So let's jump into it. So just like the last sample we covered with graphics, in this one we're going to be going through it bit by bit. So the first thing I will highlight is we are using another header library, just like for the PNG. This time we're using a wave decoding library. We're using Dr. Wave. And once again, this is something that I would recommend you use a library for, because decoding these file formats can be hell, and there's no reason to really reinvent the wheel, especially against something that's been tested and used. So Dr. Wave is one of those libraries, and it doesn't really need any dependencies, which is a huge bonus for us. So we're going to be playing a signed 16-bit PCM wave, which there is a file of included in the sample as well. It is a song file that I actually have the rights to through the the service that I use for Twitch streams. So just like with videos, in audio we have to open up a handle. So we do that through the audio out library, and we open it on behalf of the system user. Then we just use Dr. Wave's init file, and we pass it the path of the wave file that we want to decode. Now, once again, just like video, if you watch that video, you'll notice that I talked about sandboxing, and we had to use the /app0 prefix in the path. That's exactly what we're doing here. It's basically the same directory as where we put the logo PNG. So you're going to want to put your wave in the package file, and this is how you're going to access it, is through the sandboxed path. So once we have that, we just have to get a sample count. That's really easy because the decoding library provides that for us through the total PCM frame count, and then we just multiply that by the number of channels that we have, which is 2. And then the sample data we just allocate on the heap for all the sample data. Now, in the last video, I mentioned that the heap is quite limited on the PS4. In the Toolchain case, you get a lot more access to heap memory than most applications do normally, because we can kind of break that limit through our own custom CRT. So our CRT allows you to use up to like 700 or 800 megabytes of heap space, and this is going to be plenty for the audio sample data. So that's why we're allocating it on the heap here. You could also use direct memory here as well if you wanted to. Okay, then we just decode the WAV file into the buffer we just allocated, and then we simply do a while loop, and we play the song. So how we do that is we get the sample data from where we decoded the WAV file into, and we pass that sample into SCE audio out output, and we just continue advancing the offset to where we read the samples from by 256 times 2. And the reason we do that is each sample size is 256 bytes, and then we multiply it by 2 because there's 2 channels. Now, you could make it play in a loop, which is actually what we do. You could also make it only play once, so you can make it so finish is set to true, and you just break out of it. But basically, because all the sample does is play audio, we don't do that, because then you would just uninitialize the Dr. Wave. You would free the sample data, and then you would just do an infinite loop that does nothing. So instead of that, the sample just plays the song on a loop, but you don't have to do that, obviously. You can just make it play once and make it a one and done. This is just a sample to show you how to play WAV files. As you can see, this is far simpler than... Oh, that's interesting why it's not showing in that. This is a Visual Studio quirk. The file is actually there because it builds. Anyway, this is a lot simpler than the graphics or 2D sample we did last time, because playing audio is a little bit easier, especially when you use the library to decode the wave. The Sony libraries make it pretty easy to do this, so because we have the stub set up, you can just call those functions. Once again, I will go to the header. This is the header we have set up for the audio functions. So you can see we have a few of them reversed here in the types, but there is a lot here that still needs reversing. So once again, an area that contribution would be really helpful on. Now, because we are using system libraries, we will look at the build script. Just like with the video sample, instead of linking in SCE video out, we're linking in SCE audio out, and we're also linking in the user service, because I think we needed that to get the system user or something like that. It's been a little while since I looked at this sample, but I'm pretty sure we needed it for that. Anyway, this is, again, just to highlight, this is where you put your libraries that you need to link in. That way you don't get any linker errors when you go to build the sample. So once again, we go to build solution, and down here it will build all the object files and it will link it in, and we have the final file. Now that we have these, we're not going to take this sample, but we're going to take the last sample just because it's a little bit easier to capture. We're going to be taking the image sample and we're going to be creating a package file, installing it on the PS4 and running it, just to show you guys how that process works for when you're testing your own homebrew and when you eventually release your homebrew. So we're going to get into that right now.